Good morning, everyone, and welcome to our next session of our Always On virtual series. This virtual series is designed to provide you with thought leadership throughout the year and provide a deep dive into the trends that are transforming the way we do business. During each session, we will be joined by Carousel's own Chief Technology Officer, Jason Vieira, who will identify the right mix of topics and speakers to advance your IT strategy and enlighten you on hot-button issues and industry trends. Today, we are joined by Director of Infrastructure Solutions, John Elliott, and Carousel's Director of Engineering Solutions, Chris Williams, who will discuss the impact of Wi-Fi 6 and 5G on organizations. Before we begin, just a few housekeeping items. We have provided our speakers' bios in the top left corner of your screen. In that window, we have provided shortcuts to our speakers' social media pages. Please take a moment and connect with Jason and John on their respective social media channels. At the end of today's session, Jason, John, and Chris will address your questions. Please use the Q&A function below the presentation to submit any questions you would like to ask our presenters. And with that, I will turn it over to John.
Hello, everyone. Thanks for joining us today as we talk a little bit about Wi-Fi 6 and a little bit about 5G and the evolutionary changes that are kind of going on in the industry. Again, my name's John Elliott. I'm the Director of Infrastructure Solutions here, and I'm joined by Chris Williams. He'll be answering some of the Q&A panels. There is a Q&A panel you can access. Feel free to be adding questions to it. We'll try to answer some of them on the call itself and some of them in the Q&A panel, depending on whether they seem like they're applicable to the larger group or not. So with that, let's just dive right in. Wi-Fi obviously has been around for a long time. We have this new Wi-Fi Alliance lingo, Wi-Fi 6. It overlaps heavily with 802.1ax. For those of you who are not familiar, the Wi-Fi Alliance is actually an industry alliance of vendors that come together to promote new technologies a little faster than maybe the IEEE, who's the governing body behind the standards. So the IEEE, the Institute of Electrical Engineering, has a standard called 802.11ax, and like most of the 802.11 standards, they all came from the IEEE. But the Wi-Fi Alliance, in order to try to get features out more quickly, ever since, let's say, 802.11a, they've been banding together, and these are the major players like the HPEs and the Ciscos and the chip vendors like the old Marvells and whatnot, Broadcom's getting together to kind of promote the standard and interoperability. They do interoperability testing. And over the years, we've had B, G, AG, N, AC, and now AX. So for those of you who've been in the industry for a while, you're familiar with this trend. You've seen it go. It is a little bit of an evolution. It's not necessarily a revolution, but there are some definite changes in the air. And I think from a use case perspective, we are finally getting to a point where we'll start to see something different and unique as we move into the AC realm and certainly when we move into AX in the next year or two. So the idea behind Wi-Fi 6 and 5G is essentially to enable what I'll call the mobile workplace or the mobile lifestyle that for more or less we've become accustomed to, that you go from a Wi-Fi environment, you go to a cellular environment, you have a device that has a cellular data plan, whether that's like a wearable like a watch, a smartphone, or a tablet type device, and you can go into corporate offices, out onto the road, into restaurants, wherever you are. It should work the same way. It should be ubiquitous. It should be transparent to the user. Now, to a great extent, we started to get this, I would say, probably starting in around 4G. I think 3G, 4G. 3G was really too slow. It wasn't a transparent experience. But as we get into 4G and certainly as 5G comes along, we'll really be able to go essentially wherever we want, whenever we want, and have continuous access. And that's actually probably going to mean some new things and some new use cases as we go along here. Now, one thing I did want to talk about is a little bit about timelines. We're going to spend a lot of time today talking a little bit about Wi-Fi 6 and a little less time talking about 5G. And it's not that 5G will not be an evolution or a revolution in technology. It's that right now, the number of clients that are available, and this is true for both Wi-Fi 6 and 5G, are very limited. Things like some 5G hotspots, and also deployment is fairly limited. We're talking about major cities in U.S., in major Western areas like EMEA or Japan. So it's going to take a little while longer to get a ubiquitous kind of access in the 5G and carrier space, because not only do we have to upgrade clients, we need to upgrade cell towers and backhauls and things like that the carriers are busy doing, but it will take some time to do. So having said that, we do work with all the major carriers. We have a carrier division that can help you find the right carrier choices if that's a direction you want to head down and you need to kind of prepare for the future that's coming up. The flip side of that is 5G, or Wi-Fi 6, sorry. I get these. Wi-Fi 6 is that the clients are still kind of sparse, but from an infrastructure perspective, if you want to take a building, if you want to take a field, if you want to take a warehouse, if you want to take any kind of facility, you can build that out right away, right? The clients are a little bit sparse still, but they're coming along. So from a realistic deployment perspective, we're at a point now that we can really start looking at Wi-Fi 6, and for 5G, we're really more in a trial it out in limited areas kind of scenario. So again, having said that, all of this will come around. It's really just a year or two. It may seem like a long time, but for those of you that have been in the industry, you probably realize that you blink your eyes and it's next summer, and a lot of these things that you thought were a long way away are very nearby. So what are we looking at, right? It's really the same split, carrier versus on-prem, capacity and density favoring Wi-Fi 6, and cost in a lot of cases, where we really want large numbers of people, where you want corporate control, where you want to provide, let's say in a retail space, you may want to provide Wi-Fi sticks so you can track who's coming in and out, that you can offer Wi-Fi, you can do some captive portal stuff, see who they are, who's coming through your store, where they are in your store, where they're lingering. Obviously, for an enterprise, you may want to provide Wi-Fi just for a corporate resource perspective as well. One of the new areas that we're probably going to see both for Wi-Fi 6 and 5G is IoT. And we'll talk about specific features that are part of 802.11ax Wi-Fi 6, as well as 5G, that are going to enable these very small, low battery transmitters to be much more effective in the sense that they'll be able to stay around and online for, months and months, potentially, and maybe even a year or more, as opposed to hours or days, like a typical wearable today where you might have to charge it every night. So a lot of interesting things happening in this space as the technology evolves and gets rolled out. So having said that, we are looking at doing more Wi-Fi 6 in the near term. And some of the capabilities we're going to get is, again, IoT. This is because of lower latency to some extent, but also improved battery management. So going from left to right, obviously higher data rates, that's almost a given as it evolves. This will enable a few new applications, such as 4K video, ultra high def, it may be called, or virtual reality. For the most part, I don't think this actually is a very big driver, is that I don't think a lot of applications today are capacity constrained. It's really where we're going to use that network capacity, and where we're going to get that capacity is not for specific applications, but for scale. So where you may have had a classroom of 400 people, or a conference room of 100 people, or an auditorium, or a basketball stadium, where it might have been very difficult to provide adequate capacity for the number of users, we're going to have much better ways of handling that with Wi-Fi 6 as we go along. I talked about the IoT already a little bit, and I think we're going to see fairly fast device adoption. Again, we're not seeing a lot of 802.11ax devices yet, but given the power efficiencies that we're going to see with 802.11x that we'll talk about a little later, I think that it will be in the best interest for a lot of vendors that provide handheld battery-operated type devices to adopt this relatively quickly. So, again, scale, high bandwidth to every user, ability to get low-powered battery devices working well for long periods of time without having to replace batteries, weekly or daily, or charge them or provide power. One thing that's a little different that's also enabled by some of these technologies is that both 5G and Wi-Fi 6 have much lower latency, and we'll talk about some of the technologies that make that happen and are available to make that happen, and that'll allow more real-time type processes to occur. Now, reliability with wireless, it will be a little better with Wi-Fi 6, but life safety kind of things, we probably still are not going to run over wireless, but the ability to run applications that require very tight latencies are going to be much improved when we get to Wi-Fi 6. So I know I covered a lot there, and I know we have a big and diverse audience. Depending on where you are, what your market is, what your needs are, some or all of these things may make sense for you or they may not. So with that, I think we're going to dive into a poll question here. And it's really about Wi-Fi 6 and 5G and your plans in the next year. As an industry, we're seeing that Wi-Fi 6 is a little more mature. We expect that to happen a little more quickly, and then the 5G deployments to happen a little bit later. However, you may have use cases and applications that really are outdoors or widespread where you're looking for carrier 5G. And even if the trials may be in limited areas, you might be looking to do that and looking for carrier partners to help you with. So this is kind of a poll here. Are you looking at Wi-Fi 6 in the next year? Are you looking at 5G in the next year? Are you looking at both? Are you looking at neither? Hopefully there won't be too many people that are saying neither, because probably came to the wrong webinar. But I think I'm going to give people another 10 or 15 seconds to answer the poll, and then we'll bring it up here on the next slide to see what the answers were. So we're going to pause for just a second. And after you've answered the poll, also if you have any Q&A, this might be a good time to type some Q&As on this overview section before we move on to the technology behind all this stuff. Okay, let's see what we got for surprising number of people, almost half, are really just here to learn more about the technology. They don't have any near-term plans or use cases. There is a significant minority, though, that have needs for 5G, even though the carriers are probably not well positioned to deliver it in the near term. So not surprising, a little more 5G interest than I would have thought, but that's good to know. Again, we do have a carrier team that can help you work with finding the right carriers in the right places to help enable those plans and use cases that may come along. But with that, I'm going to dive into a little bit of the technology here. Now, a little bit of an eye chart here. We're going to be going through a lot of buzzwords, and I'm going to first introduce you to those buzzwords in the next couple of slides. And then we're going to take some select technologies that are enabled by 802.11ax and Wi-Fi 6 and discuss them in a little more detail and discuss the benefits that you're going to get out of that. So one is OFDMA, so orthogonal frequency division multiplexing, which we've had for a while. OFDMA actually allows a little better use of the stuff, and we'll talk more about that as we go along here. So the other thing that's a little bit more advanced now is the multi-user MIMO. We did have some multi-user MIMO in 802.11ac, but it is become a little bit better. And we'll talk about that technology as well and what that actually means and how it works. The other things we're going to talk about is target wake time. This is the ability to have things sleep for longer periods of time. And of course, higher bandwidth, like using techniques like 1024 QAM. So again, I'm going to dive into some of these as we go along here in a little more detail. The obvious thing with the evolution in Wi-Fi is that it gets faster and faster. We are using a modulation called 1024 QAM. That's the number of bits we stuff into a symbol that we send over the air. The more data we try to pack into the symbol space, the harder it is to decode. So this will come up a little bit later. What we're going to be looking at is that as we go faster and faster from a space perspective, we may want to look at our coverage patterns and where we can deliver these types of services. So if you have an actual use case where you want this high bandwidth or low latency, the coverage patterns that you have today or the number of APs that you have today really may not be adequate to cover the space that you have today at the rates that you want to achieve in the future. So we'll talk a little bit about physical design, design constraints, antenna patterns, things along those lines as we move along here. So the other thing I want to talk a little bit about is orthogonal OFDM, or frequency division multiplexing. So OFDM has been around actually since 802.11a, and at a high level, it takes a channel and breaks it up into what are called subcarriers or smaller transmit bundles. So if you look at this picture here, if you go from left to right, there's a 20 megahertz channel, which is the standard channel width on 802.11. With OFDM, we broke it up into smaller chunks. Now, the reason we break it up into smaller chunks is that, one, we can fill that bandwidth gap more efficiently for some physics reasons that we won't get into today. But the other thing that we can do is we can actually assign different users to different subcarriers and get more efficient utilization as opposed to essentially just trying to send a bunch of stuff at very high frequencies. Now, what happens in 802.11ax is that we have the ability now to essentially take those slots that we have over the air and have multiple users share that slot. This leads to much, much higher efficiency from an airspace perspective when you have small packets. Now, why would I have small packets? Well, a good use case would be voice and video. So this is with the previous Wi-Fi standard Wi-Fi 5. You'll notice that because voice in particular, and to some extent video, generates a lot of small packets, the way Wi-Fi handled small packets is really not well optimized. It was really designed more for those throughput drag strip type testing. It's like, oh, I can get 1 gig of throughput. Well, you can get 1 gig of throughput if you're doing a file transfer, but if you have like 40 people trying to do something like voice calls on Skype or Ring Central or a Cisco call control system, you're not going to achieve anywhere near those kinds of throughputs because of the low efficiencies in AC. One of the things that's changed here is the ability to pack more and more small frames into the airspace much more efficiently. So 2 to 3 times increase in voice capacity. Now, I highlighted voice because we have some research here and it's very easy to see the dramatic change. This also helps in IoT type applications. So IoT generally are sensors. They're usually battery operated devices. They're usually monitoring things or reporting things. They're usually sending data in very small chunks, but there may be a very large number of them spread over a large area. So from a cost perspective, this may be kind of the opposite of what we're talking about before. We may be able to have a large number of sensors covered by a low number of APs using a highly efficient way of packing things into this uplink scheduling that we have as part of 802.11ax, or 802.11ax, sorry. So a lot of different use cases around being able to handle small packets. some extent video as well. The next thing I want to talk a little bit about is multi-user MIMO. Now this started with 802.11 AC, which was the previous version. And so essentially the idea is that you have multiple antennas on your AP, you can send to multiple clients at the same time. Now this started to be introduced in AC, and it evolved in AX, and the fundamental problem is that you can have an access point, which is a fairly large unit. You can put multiple antennas on it. It can transmit what are called spatial streams, 3, 4 spatial streams at a time, 2, 3, or 4, depending on the access point, and talk to different clients. Now, if you have something like a laptop, yes, I can put 2 antennas behind the screen, maybe 3, and I can achieve like multi-hundred megabits per second throughputs because I have that space. If you have something like a wearable, like a watch or a smartphone, you may not have the luxury of putting 3 or 4 antennas into that small space. They physically just don't fit. So the high throughput is wasted on something like an environment where you have a lot of small wearable devices, a lot of iPhones and Galaxy smartphones, things along those, watches. But we gain that back by using this multi-user MIMO. We can talk to individual devices simultaneously, more like it's a switched environment as opposed to a hub environment before. So between the higher throughput that we're seeing in the industry and the essentially where we are today with multi-user MIMO, and we're able to achieve much higher throughputs, much higher densities. I think some of the vendors, starting all the way back to 802.11a, we're talking about the wireless office. Now, I think for a lot of office spaces, if you're in a call center, people never move, wired connections are probably still the most cost-effective. But in a lot of office environments now, for example, I'm working on a Mac here. I have a backup device that's an iPad. Neither one of them have an Ethernet port. They are primarily wireless, and I can add Ethernet by having a dongle that hangs off. But we really are at that paradigm shift now where the devices are not even coming with wired ports. Things like even Windows devices now have come without Ethernet ports. A lot of times they're designed to be primarily wireless. And this capacity that we have between MIMO and 802.11a, C, and AX really are going to enable that, what I'll call wireless office that people have been talking about for many years now. In fact, we're starting to see for deployments now where the number of switch ports is going down, the number of access points is going up. And we'll talk more about physical deployments as we go along here. But I just want to bring this up that these technologies are going to change the way we design a lot of networks, not just office networks, but warehouse networks, classroom networks, those sorts of environments, as we move more toward essentially a fully wireless environment. I'm going to talk a little bit about multi-in, multi-out and how it works and the physics behind it. I'm not going to spend a lot of time on this, but it's kind of an interesting thing, a phenomena called beam steering. What you can do is, with multiple antennas, you can send out ripples or waves, the radio waves out. And when 2 radio waves meet, they amplify one another. And when 2 radio waves that are opposite meet, they cancel each other out. You may have seen this phenomena if you, for those of you that still use FM radios in your car and are not streaming, you may be in a spot where you stop at a stop sign and the radio is very weak, but you creep up a couple of feet and all of a sudden it comes in very strong. You may have been in a radio null where the radio waves are bouncing off of something and are essentially canceling out in that very small spot. What's interesting about MIMO is the ability to actually by precisely timing when the waves are leaving the different antennas, to put those spots where the waves amplify each other where the clients are. It's a very interesting technology to be able to track the clients, find them, map the timings correctly, transmit, and these very small time scales in order to get the clients in the right ripple points. And where that actually helps is that you can talk to specific clients, and other clients that are not at those ripple points don't hear that interfering signal nearly as strongly. So there's a lot of very advanced stuff going into both AC and AX to make the capacity so that you really have more of a switch type environment, as opposed to the old radio days of 802.11a or even N, where you blasted out to everyone heard everything, and if someone was busy, you had to wait, right? There's a lot of advanced work that's been going on in the industry that says, like, I can talk to you and I can talk to someone else, and I can talk to you at the same time, and you will not interfere with one another. So again, a lot of changes, a lot of it's under the covers, a lot of it's physics and math, and it may be a little hard to understand, but the gist of it is that from a capacity perspective, we have way more capacity now, just from not only from a raw throughput perspective, but an effective utilization perspective, and the ability to talk to many people at the same time from one access point. So again, a lot of subtle behind the scene changes that are going to allow this kind of new environment. And I know I'm talking a lot about 802.11ax at this point. From a 5G perspective, a lot of these things actually came from the cellular world and go back as far as some of these things like multi-use or MIMO go back to, I think, to 3G or 4G. So in a lot of ways, a lot of the things you're seeing in Wi-Fi 6 now are really adopting technologies that the carriers have been dealing with for a long time, because they've always had the problem of scale, many users, large densities, right? We're starting to take those techniques that we took out of the cellular world and putting them into an access point that you can use in your enterprise environment. The last thing I'm going to talk about here, I think it's the last thing, maybe the next to last thing here, is target wake time. This is both an IoT and a wearable and handheld device thing or feature. It's a very simple concept. And I always start on the right of the slide and move to the left. I apologize. I did that before, but let's start with the target wake time since I started talking about that. Target wake time essentially, battery-powered devices want to sleep, right? They don't want to be up all the time. They don't want to have the radio on, powering the radio. They want to be able to shut down the radio and potentially shut down the processor to extend the battery life. If you're in a noisy radio environment and you're getting a lot of multicast and you're constantly talking to your iPhones and your wearables and your smartphones and your tablets, the batteries are going to go dead very quickly. So the idea behind target wake time is that we can put a device to sleep and say, you can go to sleep for 500 milliseconds or maybe even a full second. The standard, I think, allows for several years of sleep time. And we will hold your packet and you won't miss it. So when you wake up, we will send the frame out at that time. So, if you get a phone call or a text message or an email while you go to sleep to save power, you won't miss it. The AP will hold it and we'll send it out when the target time is for you to wake up. This is going to have a fair, now some of this was in AC, but a little more work's been done in AX. This is going to have a significant impact on battery life for handheld devices. I think it's one of those benefits that people aren't even going to realize that they have it, other than the fact that like their phones and their watches are not going to be dead at the end of the day anymore. Now, the other place where this helps out is IoT-type devices. Again, the small battery-operated things where you may have tags that are attached to devices that are battery-operated. The ability to have something that, let's say, is a location tracking tag where you only maybe need to talk to it once an hour. Essentially having that device only wake up every hour or maybe even once a day. Potentially, you could have a device that sits out there for months and months and doesn't need a battery replacement or doesn't need a recharge, right? Whereas today, if you have something like a Wi-Fi tag, you're lucky if you can get it to run a couple of days or even a week. So this, again, a whole new class of applications for user tracking, device tracking, resource and physical inventory tracking, IoT type things that only need to report occasionally, being able to put out in the field without power, a whole new use case, a whole new family of applications that will be enabled by this technology. So the other thing that we're talking about here is the resource units, the ability to be able to use very small channels. And this is actually going to help in some older, lower power devices where we're not going to blast out the entire channel space in order to talk to a device. So if you're using Bluetooth, if you're using Zigbee, if you're using some other type of technology that's competing in the same space, if we're not sending a lot of data, we're not going to hog a lot of the physical bandwidth, the width of the channel. We're going to use a very narrow portion of the channel to talk. So your Bluetooth won't be interfered with, your Zigbee won't be interfered with, a lot friendlier interaction with life. So with that, I know I talked a lot about features here. I'm going to review them very quickly, but I'll give you a couple of minutes now to kind of answer the poll question here. Which features are you really looking for that you've heard about from a Wi-Fi 6 perspective? The target wake time, which would allow IoT type devices, battery operated devices, longer battery life. We only allowed you to get one choice here. The narrowband resource units, are you really looking to get more optimal utilization for large numbers of clients or co-channel interference with other things like Bluetooth? Is that an important thing for you? Are you looking for multi-user MIMO to get that capacity to talk to a large number of users or a large number of devices in a single space? OFDMA, are you looking to pack lots and lots of small things into frames like video or audio? Which of these things are most interesting from a use case perspective in your particular environment? So I'm going to give you maybe a couple more seconds here because I think a lot of you probably heard and have already answered this, but I just want to review the questions really quickly. We'll give you about 5 or 10 more seconds, and then we'll move on to the answers. Let's see what we have so far here. So multi-user MIMO, and I think that is, I'm going to guess then that most of the people here that are looking at multi-user MIMO, OFDMA, and these are really applicable in high-density enterprise-type environments where you need capacity, either for lots of users or just raw throughput. So again, every use case is different. Depending on what you're trying to do, target wait time could be very important, but this is not terribly surprising. These are kind of the results I expected, so that's always good. So moving on, I talked a little bit about how your physical plant may change or it might be better to change your physical environment a little bit. I'm not saying that you have to. The new APs are fully backwards compatible. If you, just like the older APs, if you go into your environment and you put 802.11ax APs in the same places you have 802.11n APs, it will work better than your 802.11n environment does. Will you be able to get 802.11ax Wi-Fi 6 throughput in every corner of every part of your building without moving some things around? Maybe not. That may or may not be important depending on your use case, though, and the cost of doing that. One of the things we're going to talk about today, or the value add that Carousel Industries can provide, is that we do have a lot of expertise in designing these types of environments and a wide variety of environments, not just general office space with overlapping signals, but warehouse-type environments or high-density environments like auditoriums and stadiums and classrooms, down to small business remote locations that have a single access point. So You know, the baseline type of survey, passive RF, this is kind of built into the controllers. This is typically what you'll see in the general office environment. You'll put out APs, you'll put them a little closer than you probably need them, or a lot closer than you probably need them. There's some sort of intelligence, either in the cloud or in a controller, or maybe even in the APs itself. They communicate around with each other, and they reduce the signal strength or adjust the signal strength to optimize the coverage. You know, we can do more measurements, get a little more insight into figuring out why things are going wrong. Almost all the vendors today provide some sort of delay metrics or latency metrics for the performance of the Wi-Fi, performance of clients, the ability to give you some idea of why things are going wrong, when they're going wrong, what times of day they're going wrong. And then there's a lot of what we're doing today are predictive site surveys. These are essentially software driven. We'll give a floor plan, we'll give the characteristics of an antenna or AP. We will try to estimate obstacles in the space, walls and partitions, and the expected dB losses at a given signal frequency, and better estimate how we might want to place APs as opposed to traditional, like, hey, I'm going to stick an AP every 75 feet, right? So a lot of different surveys we can do, both in front and after, before and after, to kind of optimize the environment. And again, it really depends on the environment. So stadiums, arenas, classrooms, we may want, you see here, under seat placement, down tilt antennas, and these are all things that actually minimize the amount of coverage. And that may be counterintuitive. It's like, why would I want to minimize the amount of coverage I have? Well, you may be in a stadium that has 40, 50,000 people in it. Now, if that stadium were empty, I could put a high gain Omni antenna on the 50-yard line, attach it to the AP, and I could probably talk to any device anywhere in that stadium across that open airspace, you know, within a couple hundred yards. Now, the obvious challenge with that is I'm trying to talk to 50,000 devices. That's going to break down. So we design these types of environments where we create these microcells, either by placing the antennas in very specific areas to reduce the coverage, or using very specific antennas, which we'll talk about in a little bit, that minimize the coverage area so you can cover the amount of people that you want, or the number of devices you want, in a very small area, and provide those that coverage. Now, one thing that has changed a little bit, 802.11ax actually has better client management as well. It will take a little while for these benefits to be realized, because we're going to need a significant percentage of the clients to be enabled before we can do this. But we do have some transmit intelligence, power level intelligence in, I think this came out around the 802.11n timeframe. There's a different 802.11 standard for it. But AX has done quite a bit of work in order to optimize these high-density, noisy environments, so that not only can we get the AP to be talking at a low volume, your client, tablet, or watch, or phone may be transmitting at a very low power as well. So overall improving the experience for everyone. Now, from a design perspective, 2.4 versus 5 gigahertz, these are the two bands Wi-Fi runs in. We're starting to see a lot more designs now where we're reducing the number of 2.4 gigahertz radios. A lot of the vendors now are supporting multiple 5 gig radios, so we may have, because of both the inability to go through obstacles and the smaller coverage at the higher frequency, a lot more 5 gig radios. So typically in the old days, you put up an AP, the AP would run 802.11n, it would run 2.4, it would run 5. What we're seeing these days are more designs where, you know, 2.4 may be every other AP, but every AP would be running 1 or 2 channels of 5 gigahertz in order to provide more capacity. So again, some changes in design based on the available bandwidth in the band that we're talking about. So a little different way of doing things that we might have had in your existing environment if we were going to build it from scratch. Now, having said all this, you obviously have to decide whether the benefits of changing the design outweigh the cost of changing the design. Having said all that, it's, is it worthwhile? It really, for new builds, I'd really encourage you to look at some of these new design techniques like more 5G, antenna selection, things along those lines. We'd have to go back and look at an existing environment. It may or may not be worthwhile to try to retrofit. And the other thing I'm going to talk about here is antenna selection. I talked a little bit about this. The Omni on the right-hand side covers a very, very large area. And that tends to be the old-fashioned way of doing things. I put an AP in, I try to cover as much as possible. What we're seeing today, because of the higher densities, we're moving more toward patch-type antennas or even Yagis or sector antennas. Like in an auditorium where we can't put things down on the floor because we're afraid the students will steal the APs. We'll still do things like putting highly directional antennas into the ceiling so that multiple APs can cover an auditorium or classroom because each is covering a very small part of the floor space. So I can have 400 people in a room, and they can all have good Wi-Fi. Large events like an announcement by Apple or a vendor conference like, let's say, Cisco Live, where they'll literally have thousands of people in a room, use these types of techniques to enable high-performance Wi-Fi in a very large area. So, again, if you have these kinds of issues, if you have these kinds of rooms, if you have these kinds of spaces, this is one area that I think we can really help with our expertise in designing the right solution to give you the performance you want, balanced with the cost that you want to pay for that performance. So obviously you can always get more and more performance if you pay more and more money, but usually this is a balancing act that we have to have with our customers. So there's some basic things here that we're going to talk about. SSID channel power considerations. I talked about the power a little bit. AX did a little bit of work to help with overlapping cell sizes. There's a little more intelligence around overlapping cells and power management that isn't in AC. But even without those improvements, setting the right transmit power, even in 802.11, I think as far back as N, usually the client will honor the transmit power of the AP. These are all basic design things paired with the right antennas that can really improve your user experience from a utilization perspective. Now, having said this, in a typical office environment, a controller or a cloud-based system handles a lot of these parameters fairly well, effectively, as long as you don't have any kind of corner cases to deal with. But it is, from a troubleshooting and design perspective, something to be aware of, right? The number of broadcasts you're sending out, either because you have too many SSIDs, how your cell site sizes are sized, whether they're potentially too big, transmitting of too much power and causing interference with adjacent cells, all things that are part of basic Wi-Fi design. To be honest, it goes all the way back to 802.11 or 802.11b. The other things that come up in wireless, and I don't know why we're starting to see this in wired as well. From a troubleshooting perspective, we talked a little bit about that ability to see latency, the ability to see jitter, a lot more troubleshooting tools now in most of the management systems from almost all the vendors. But we talked before about reducing the number of SSIDs that people can pick from because that generates essentially garbage in the air. Well, maybe I want to have multiple VLANs or multiple security policies. How do I handle that? Using effectively 802.1x and Active Directory groups or LDAP groups and assigning people to the right policy, potentially even though they're using the same SSID. These are the kinds of things that we can do with with relatively sophisticated systems now from an identity and control perspective. And not just assigning them the right VLAN or assigning the right access control list, things like, does the user have antivirus? Is it a corporate asset? Is it a bring your own device? Is it a guest portal type thing? These are all things that tend to come up in the wireless environment that are unique to wireless that often people don't do in the wired environment. So most of you have probably dealt with most of these issues. But again, we have a lot of expertise in rolling these out, designing these systems, and designing these solutions in order to meet your needs. And again, unique use cases. You may be a retail environment. You may want to know where people are hanging out with their, you put up an end cap in a store. Are people lingering there? Was it effective? There may be things that you can do with a wireless environment that are not necessarily obvious, other than just provide a connection to Facebook. So that was kind of the end of it. We talked a little bit about the market trends, where we see 5G, where we see Wi-Fi 6. We talked a lot about the technologies that are used, and I know a lot of the slides were Wi-Fi 6 specific, but a lot of those technologies, believe it or not, are actually the same. OFDMA, for example, was in 5G, and 4G goes all the way back to LTE, I think even before then. So a lot of these technologies are borrowed from one another. So learning the underlying technologies for one will help you understand when you're talking to the vendor of another one. So again, a lot of overlap here. And, physical install was something that we did talk about. That is an area that we can really help, I think, a lot of people out in. We do a lot of things in both a physical design, antenna placement, access control design, all of these things that we're really have a lot of experience at. If you have any questions, feel free to reach out to our team. We can certainly help you out with that. And with that, I'm going to put out a final survey. And this is really around a lot of that, now that we've talked about the changes that might be required for Wi-Fi 6, would you be looking to do a redesign as part of a Wi-Fi 6 deployment? Simple yes or no. I'll probably only leave about 5 or 10 seconds for this, and this will be our last question before we wrap up here. And then I'll ask Chris if we had any questions that we couldn't answer or that we should cover, and then we'll probably wrap it up here. So with that, let's see if... Okay, so yeah, people see that Wi-Fi 6 or AC even are potentially significantly different enough that we might have to do some physical design work. So that's good. Hopefully that actually made sense to some people. So with that, Chris, I don't know if you're still on, but were there any questions that you felt like were broadly applicable that we might that we should probably kind of cover with everyone, or were we able to answer most of them in the Q&A window?
Yeah, so I'm still here. There were a couple questions that we were able to take care of in the Q&A. One was more of a statement that I feel like is worth mentioning. We cannot plan to use a technology that may not be fully developed by next year, but need to know the architecture for future needs. So I completely agree. I think that absolutely makes sense. The technology behind 802.11ax is going to be a rip and replace of your existing access points. Because it requires new radios, it takes up more resources, it requires more memory in the access points themselves. But if you are an early adopter of those new APs and those new radios, all of the features that we're talking about here, so OFDMA and the target wake-up timers and the up to 8x8 multi-user MIMO and all of those things will be software upgrades. So it's similar to the situation that we were in with Draft N versus the ratified version of N. We were still trying to play catch-up, but we had to get the capabilities of the radios in place prior to being able to utilize that functionality. One of the other questions was based on the implications on the LAN. So some of the things that we have to think about there are a lot of these AX access points are being built with multi-gig ports in the back of them. Multi-gig technology is supported on Cat 5e and Cat 6. So you don't necessarily need to run multiple cabling runs to your APs. If you're looking for redundancy, it's a good option. But some of the other implications would be in your IDF closets. What are the capabilities of that switch? Do they have the ability to use PoE Plus to provide the right amount of power to support 8x8 multi-user MIMO? Do you have the UPSs in those closets to be able to support a power outage if you are increasing the power supplies in the switches themselves? And then also the uplinks back to your MDFs. Are they 10 gig? Are they 1 gig? Are you going to max out the bandwidth between your remote closets and your main closet in each one of your buildings? So those are some of the design considerations that we need on that end. We talked about the design considerations on the wireless side with some of the different antenna types, but there's a little bit more that goes into the back-end architecture to be able to support this, because with all of these things like OFDMA, there is a potential to max out a single 1 gig uplink to an access point, whereas it was very difficult to do that in the past with AC and AC Wave 2.
Okay, so with that, Dave, I think we're done with the presentation part.
All right. Well, thank you, everyone, for joining today's session for Carousel's monthly Always On Virtual Series. Shortly after we wrap, a survey window will pop up requesting your input on today's session, as well as your interest in future topics. As a thank you for taking the time to complete the survey, we will send you a Starbucks gift card, so your next cup of Joe is on us. Next month, we will be joined by Carousel's VP of Contact Center Solutions, Stephen Drew, to discuss emerging trends in contact center. Thank you again, everyone, and enjoy the rest of your day.